Guys, good morning. My topic for this afternoon is integration by using partial fractions under case number 3. Case number 3 is quadratic factors only. If the partial fraction contains quadratic factors only, this will be the solution. I will discuss this afternoon. Okay, let's proceed. Our topic is integration by partial fraction. Case number 3. Case number 3 is quadratic factors only, meaning the given function is a quadratic equation. I'll try to bring out the form. The form under case number 3 will be something like this. f1 of x over f2 of x equal to the right hand side, a quantity 2px plus q. The denominator is now the quadratic factor, px squared plus qx plus r. This is a quadratic equation. That's why our topic for today involves partial fraction that involves only quadratic factors. This is a quadratic factor plus b all over the given quadratic factor. The significance of this, for every quadratic factor, this will be the form, the equivalent form. If you try to resolve that quadratic factor, the equivalent will be a times the quantity 2px plus q all over the given quadratic factor plus a second constant b all over the given quadratic factor. Quadratic meaning the equation is a quadratic equation, where the value of f2 of x is px squared plus qx plus r. This is a quadratic equation. That's why our topic is quadratic factors only under partial fraction. Okay? Just follow this form here. Find for the value of a and b, then try to integrate. It's as simple as that one, guys. Okay, I will give example number 1. It's an easy one. It's easy to visualize, Find the integral of x squared dx all over x squared plus 2x plus 2. The one on the denominator is a quadratic equation. Quadratic, meaning the highest power of x is to the second power. Okay? By observation, the highest power factor of x on the numerator is 2, and on the denominator is also 2. It's a rule that if the power are equal or the numerator will be with the higher power, before the integration, try to divide first. And since this is x squared and this is x squared and they are equal, okay, we'll try to divide first. But just in case this is 3, you still divide first. But if this is 1, of course don't divide, right? Okay, let's try to divide first. We divide x squared by the denominator x squared plus 2x plus 2. The first dividend will be 1. 1. 1 times x squared is x squared. 1 times 2x is 2x. 1 times 2 is 2. Then perform the operation subtraction. That's the proper way on how to long divide even a pure number or two equations. So if we try to perform the subtraction, x squared minus x squared will be 0. Okay? 0 minus 2x will be minus 2x. 0 minus 2 will be minus 2. So minus 2x and minus 2 is the remainder. So actually, we could rewrite the given problem, the integral of x squared dx over x squared plus 2x plus 2 equal to the integral, open bracket. From our long division, the first dividend is 1, right? And this is the remainder. I just factor out to here. I bring it out. Because if we try to expand this one, this will be minus 2x minus 2. And it is this. I just factor out. So the given problem is equal to the integral of open bracket 1 minus 2 times quantity x plus 1 all over x squared plus 2x plus 2 times dx. And this is now where we perform the taking of the so-called partial fraction under quadratic factor. For 1 times dx, that's integrable now. We'll do that later. Okay. So if we try to take the equivalent of this in terms of two quadratic factors, quadratic partial fraction, we try to neglect the negative sign for the meantime. So we will just only take 2x plus 2. 2x plus 2 all over x squared plus 2x plus 2 equal to. This is the equivalent of this quadratic factor. It is this. We are following this. Right? So it will be a times 2x plus 2 all over x squared plus 2x plus 2 plus b all over x squared plus 2x plus 2. Actually, the one inside is the differential of this. The differential of x squared is 2x. The differential of 2 is just 2 times dx, right? We didn't place dx for the meantime. We are just evaluating the fraction. Okay? So, equating coefficient of like terms. To take the equivalent of this, we must have to compute for a and b. Equating coefficient of like terms, x to the first on the left hand side will be 2. The term with an x term is only 2, right? On the right hand side, this is 2ax. So it's 2a. A times 2 is a pure constant. B is a pure constant. So x to the first, the formulating equation will be 2 equal to 2a. So therefore a equal to 1. Divide both sides of the equation by 2. Right? This will cancel out. This 1 is 1. Therefore a will be 1. Okay? X to the first power. Pure constant on the left is 2. It is this. Right hand side, a times 2 is 2a plus b. But we now know the value of a. So substituting the value of a back to the new formulated equation, 2 is equal to 2 times 1 plus b. Okay? 2 times 1 is 2. We place it to the left hand side. So this will cancel out. We transpose. Therefore, b will be 0. Okay? Therefore, the given integral of x squared dx or over x squared plus 2x plus 2 equal to the integral. Okay? We are now following this. This is 1 minus open bracket. What is a? A is 1 times 2x plus 2 all over x squared plus 2x plus 2 plus, what is the value of b? This is 0 over x squared plus 2x plus 2 close bracket times dx. 0 over x squared, this will disappear. Right? So it's just a simple term now. If the second one is 0, this is now just to be close bracket multiplied by dx. Okay? Expanding 1 times dx, this should be the integral of dx minus 1 times 2x plus 2 is just 2 times the quantity x plus 1 times dx over x squared plus 2x plus 2. Okay? the value of u of this should fall under natural logarithm. The value of u is actually x squared plus 2x plus 2. du is 2x plus 2 times dx. du is 2 times the quantity x plus 1 times dx, and it is exact. Okay? So if you try to integrate this one, okay? Can you see it, guys? It will be under natural logarithm. So the final answer will be x minus the natural logarithm of x squared plus 2x plus 2 plus c. If you cannot see it, I will write the final answer on this left-hand portion. Sorry guys, my magnetic board is low. The final answer will be the integral of dx. I will write the integral of 2 times quantity x plus 1 times dx all over x squared plus 2x plus 2. This is exact. So this falls under the integral of du over u. So the final answer will be x. The integral of dx is x minus, this falls under natural logarithm. Natural logarithm of x squared plus 2x plus 2 plus c. So this is the final answer. So it's easy, guys. The integration portion is just very small. Actually, the long part of the solution is on the algebra portion. On the portion in which to take the partial fraction equivalent, meaning in the computation of the value of A and B. That's partial fraction, guys. Under case number 3, the given factor is just only quadratic factors only, meaning the highest power of the variable is to the second power. Quadratic. It is quadratic. So for every problem that you will solve, if the given denominator contains only quadratic factors, just follow this one. So it's just a matter of computing for the value of n, b by equating coefficient of like terms. Because actually we could solve for a and b, then try to substitute it back, then try to integrate, and that's the solution. Okay. Good afternoon, Los Angeles.